I stand out here in the wonders of the unknown at Hadley, I try to realize there's a fundamental truth to our nature. Man must explore. And this is exploration at its greatest.
Coffee? Check. Co-worker? Check. Ransomware, fireless attacks, and identity theft? Check, check, and check. Your teams working from home need a little help. McAfee goes wherever your workforce is, including endpoint protection, a new unified cloud edge, and the world's leading CASB. A secure remote workforce? Check. And to the hackers out there, checkmate. McAfee, the work from home securely company.
Well done. Nice to see the band. It really makes everything move along. We come to the next production from McAfee. After their little intro video, I welcome from Amsterdam, Christiaan Beek. I hope you can hear me, because I'm not sure I can hear you. Christiaan?
Yes, I'm here.
Oh,
thank you.
Perfect. Thank you very much indeed for being here. Your presentation, a touch of science. This is going to be another exciting journey into somewhere.
Oh, absolutely, absolutely. I think that there's a big perception around machine learning and all these artificial intelligence, but I try to challenge this thought, and it's about human intelligence, because we're still training the machine as humans, and teaming up with the machine can get you some really exciting results, and that's what I will showcase during the presentation.
And of course, the machine is good at analyzing a lot more information than we are as human beings too.
Absolutely, but if you visualize it, it will definitely help you a lot more to see the patterns faster than you're actually awaiting some metrics or some results.
Let's go straight on with your presentation, please, Christiaan Beek.
Thank you very much. Hello, everybody, and welcome from beautiful, sunshiny the Netherlands. And today I will give you a presentation now about how you can beat the adversary with a touch of science. My name is Christiaan Beek, and I'm a senior principal engineer at McAfee and the lead scientist within McAfee's advanced threat research team. In my team, we're chasing after nation-state activities, major cybercrime operations, but also a lot more with regards to innovation and how we actually investigate the different attacks, and actually how we translate that into maybe new innovation, maybe new some tweaks, some adjustments, and at the other hand, doing presentations like this. My background is really into forensics, into response and ethical hacking, and one of my fascinations is about space technology, which we recently published a lot of research about, and that's fascinating, that's interesting, and that keeps me busy and excited about. So one of the things is, when we talk about the current threat landscape, right? This is a question I get almost daily or weekly. Like, we have customers like, hey, tell me something about the threat landscape, or what are your observations? And honestly, sometimes it really feels like, especially in these times, when you look the amount and the volume of threats, is a painting like this. And this painting is from Frederick Moritz Retsch. And on the left side here, you can see actually in the green robe is like the devil. He's playing a game of chess against a human being, and his soul is at stake. So if he loses the game, then he will lose his soul with all the consequences and that like that. And honestly, it feels really like, if we are as defenders in the big battle in cybercrime and cyber defense, it feels like sometimes we're always losing, right? It's like we have to keep all the balls in the air, and the adversary just needs only one small mistake, and they can actually enter the network of our customers or your network, right? So is this truly the way it is? Is it truly that it seems like that cyber criminals are always winning? Actually, at the end of this presentation, you will know the answer. I will tell you the answer if cyber criminals are winning or that we as defenders are winning as well. So to give an example of what we are facing these days and the stuff we're doing is about this recent attack we covered. We call this Operation North Star, which we covered in July of this year. And we saw like social media being used as a lure and sent you a spear phishing email. And it was so well prepared. So like fake user profiles on LinkedIn. They were actually interacting over WhatsApp if you didn't respond too fast. But also the job advertisements were really well prepared. They actually went to the websites of some defense contractors around the world, which are very famous. They copy-pasted the job profiles, they put it in a document, and they sent them to you. And then actually they pulled a trick, which I will explain a little bit more after this slide. And when you open up that document, something happened. 2 steps down there, you saw actually a DLL, a driver, was actually dropping a payload in memory and started to interact with the command and control server. And as you can see on this picture here, we found out which parameters were working, what their functions were. And this is where it normally stops for us. Like when we do like analysis, we get the samples as in McAfee, for example, we analyze them, we make sure that customers are protected and covered. And if we discover the command and control server, we actually put that coverage in as well if we don't already do that. So overall, this is pretty standard. But in my team, we're really looking like, okay, how advanced are these attacks, right? What are they doing? Is there any kind of new trick they are doing? Because honestly, getting an email with a job advertisement or like a spear phishing attachment, it's pretty normal. But in this case, if you really analyze the document, the first one, the job offer, on the surface, there was nothing wrong. Like there was something like a malicious macro or there was embedded code inside. Nothing was there actually happening. So we did a bit more and deep diving. So how is it possible then that actually the document is running and within like less than a minute, I certainly have like a payload in the memory of my computer, which starts to communicate with a command and control server. So what we found out is that this particular group, and this is the group we called Hidden Cobra, they were using what we call template injection. So you have a valid Office document. Like I said, there's nothing wrong there, no hidden macros or shell code, whatever. But what they actually did, because like docx files are actually just like a map of files gathered together, in one of the XML files, they actually put in a link. As you can see on my screen here, this is like a compromised website, amsterdams.italy, and actually you see the 61.m file, which is a template file for Office. So how it works is actually you open up your innocent file underwater, it secretly goes to this website, downloads this template file, and since Word is already running and it's a template file accepted by Word, you don't need to do anything else. So immediately it's injected and executed in your memory, and the .m file is actually executed in this payload. Now I can tell you a lot about this, of course, but it's maybe better if I show you a little demo. So we created this demo document, and of course we manipulated some of the steps so you can actually see what is happening. So let's go there. So I open up this document, and underwater now it's going to this website where it actually downloads the payload. So you see my document is opened, and suddenly PowerShell is opened. And there is Mr. Rick Ashley. As you can see, and normally of course you won't see this PowerShell screen, This is a very smart and sophisticated way where adversaries try to bypass technology. And Hidden Cobra is one of the groups, but we saw like Gamma Redon is one of the groups. And we saw some other adversarial groups already starting to use this technique to try to bypass endpoint technology. One of the other things we did in this campaign was like, look, most people or analysts are actually looking at, okay, this is a malicious Office document. Okay, there's some shellcode, or there's a macro in it. Okay, flag it as malicious, and that's it. We decided, as part of like the practice we're doing with also forensics, is there more we can find out? So is there more we can do around Word and Office forensics? So we really dug into the code of the Office documents. And at some point, we even chatted with some of the technical specialists at Microsoft, like, hey, we're finding these values in the XML files. So what exactly are they representing? Because honestly, if you go through Office XML specifications, you're going through thousands of pages of documentation to find out what exactly is meant. So what we found here is actually, if you see this 6D6844 value, is this is a certain value. If you create a document, this is actually stored in one of the XML files. And what does it mean is actually, if you use that same file over and over again as a template, that same value is still in that document. And that's interesting, because honestly, if you then put out your timeline with events, with the different documents we saw in the campaign happening, we could actually go back in time and say like, hey, wait a minute, this is absolutely the root documents they have been using. The cool thing there as well was like, we found other values. So the RSIDS is a value also hidden in your Office documentation, where you can see where were changes or differences being done in the documentation. So document 1 and document 2, they had both this same XML value, as I just showed you in the previous slide. But then when we went through the table, we could actually see like, hey, the first 4 entries are the same, which means the first 4 locations or entries in the document text-wise are the same. But after that, you see the values change. So it means that's exactly the locations where they manipulated the document and where they put in different content. And all this together are really, really interesting pieces of the puzzle that can help you either detect it faster or help you answer some of your hypothesis answers you're actually trying to solve. Now, going through this particular campaign, we also discovered like, hey, we found absolutely campaign codes that were absolutely used by the adversary to track who actually they are sending this documentation or the attack towards to. And this was interesting. And I was like, okay, we think it is a campaign code, but actually later on, which I will show you, where it started as a hypothesis, we gathered more and more details where we could actually answer and say like, yes, absolutely, this is a campaign code. Another interesting fact is that when you look, for example, at one of the files we discovered, and this is like the compound file binary, the old, I would say, the doc file, there are some values there in the fields. In this file, in this case, the document summary information, if you look at that value, and we always take in considerations, values can be changed, values can be changed on purpose. So, but in the overall picture, in the overall hypothesis where you're actually gathering the technical evidence, this is one of the steps we executed as well. So what we saw is that in this case, one of the documents contained, as you can see, 10.0000, which is translated to the Microsoft documentation. We could say, okay, the adversary, in this case, used Office 2016 on his machine to create these documents, which was supported by other evidence in the XML files. Another thing which we discovered is like, hey, in the same kind of document structure, there's another value that's a possible indicator for which operating system is being used. So translating again that value, we saw, hey, he is using or she is using the Windows 10 operating system. So putting that all together, you have like, okay, it's Windows 10 OS by the adversary with Office 2016. they were using these kind of files and templates. So that slowly by slowly builds up your picture, which can help you to actually create defensive capability. As I mentioned before, normally for us, when you have those documents and you have the macro and you have you see hey, it communicates to a command and control channel and there's a first implant, that is where it mostly stops for us as companies with the research, because getting access to an adversarial command and control server, that's hardly possible, at least not for the private sector. In this case, we were very lucky. We actually found evidence, and we got the evidence, and we got control of a full command control server that was controlled by Hidden Cobra. And the amount of information we found in the log files or in the, as you can see in the scripts on that server, were fascinating, because the hypothesis we built with the campaign IDs were absolutely confirmed when we checked the code of some of these web pages in the command control server. What they actually did was actually very fascinating, I would say, is that when you logged in with your first stage implant and you were actually connected to the command and control server, it was asking a few basic questions back to the victim's machine. And based on those answers, there was a mechanism in place where it would say hey, you are on my allow list and you're a 64-bit machine and you're meeting the criteria I've set. So that's why I sent you implant number 2, which was called Charisma in memory. And we closely are going to monitor disk activity and remote desktop. And that was really fascinating to see, because if you didn't meet the criteria, it was written to a log file again, and you get an error and everything was solved out of memory, traces cleared. But there was another case where the condition was although you don't meet the primary conditions, you're still a target of interest to us. So let's put you on hold and let's decide if we send you maybe a different payload. So that whole mechanism, that's something really fascinating, which we learned about. And actually we recently published about as well on our blog page. But that was really cool to see that. And overall, when you invest as a team in doing a month of research, of course, that's a huge amount of money. And what is the benefit? Often people think hey, the public relations, the blog post, oh, that's fantastic, that's great. Of course it is. But honestly, I see it as a bonus. What I really learned and what I really was actually valuing in this case was we learned so much new investigation techniques and so much artifacts we gathered that actually helped us to develop new kind of signatures, but also a new way of actually how we can detect this. And we can translate that actually in patents which we submitted. And the cool thing is, when we actually learned about those new artifacts and investigations, we saw hey, what we learned from the office file forensics, that's something we can actually apply to the TrickBot and Emotet campaigns that are heavily using malicious office files as well to distribute their malware. So again, this was also a very cool way of actually learning about doing the stuff, translated into a machine learning model, but also just tweak existing models so that we can actually detect more. And that was overall a big win. Now, that is on data, right? And human interaction and investigation. And actually, this is something which we really are investigating a lot in our team. Of course, we have machine learning, we have artificial intelligence, which is great. It really helps us to search on data collections, which are huge, or pattern matching about things. But on the other hand, the human factor, our training, our experience, our intuition, but also, like it says here, the creativity or thinking out of the box, that combination of human and machine teaming, I would say that's a gold mine. That's something you really need to invest into. So I will give you an example as well how we actually are using this. So everybody knows ransomware is a big thing, and especially the targeted ransomware attacks where people break into your company, they steal the data, they launch the ransomware, and sometimes it is within hours, sometimes it is within a few days, but this is happening a lot. And within our team, we're monitoring the top ransomware families that are very heavily active. So we monitor all the movements, the traces, if there are new samples, do we cover it, etc., etc. At some point, we saw an increase in Ryuk ransomware, which was to us very strange because Ryuk was like a solid, small, low line with now and then an infection. And they keep very low level. They don't advertise a lot or leak about their data of their victims. So suddenly seeing an increase where we saw like 60, 80 samples per hour spiking up, that was really weird. So what we did, as you can see here, all right, what is going on here? So we grabbed the samples of that occasion and we start to analyze it. And we used graph technology. So first of all, we did on the left, what you see on the strings is like, okay, let's grab those 50 samples, and this is a small subset because otherwise it wouldn't fit on the screen here. How equal are they from a strings output perspective? Well, as you can see, all lines are thick, and so they're pretty much well connected, and so they're all the same as it looks like from a string perspective. Okay, second exercise. Again, we use our machine learning. Okay, from all those samples, show me from a hash-based perspective and from a code flow perspective, how equal are they? Still, you see here all the lines that they are interconnected. So there is some similarity, there is some flows going on. The third one was actually very interesting. Like all the samples we actually gathered from this Ryuk ransomware were compiled, so actually written on the same day. And that's weird. Like if you have a big flow of samples, yes, sometimes it can happen. So that there's one sample that's being distributed over a day, which with a lot of using a botnet or something like that, or spear phishing, that can cause, but still it's the same sample. But in this case, you had like, of course we took now 10, but we had like 80, 90, 100 samples during the same day, different samples being distributed, but all had the same compile time. So at some point you will think like, what is going on here? There must be something here that's being used or abused to do this. So we started to compare, and we grabbed like a sample on the left, a sample on the right, and if you look a little bit on the red boxes here, you can actually see that there's a difference. There are differences in the code between the original and one of the mutations. And that was interesting because like, hey, what is going on here? Does it make sense? And when we actually generated a more in-depth graphic where we said like, hey, tell me from all those samples how much code similarity and code, what we call genes, are equal, you could actually see that some of these samples are, if you can see here a little bit on the screen, some are 84% equal to each other, but others are 66%. Or there are cases where it's 87% equal. And what we learned was actually that in this case, somebody was trying to poison the AI model. So they were using what we call metamorphic code manipulation to actually try to manipulate the AI engines of us, but also of others. So what metamorphic malware actually does is like it keeps the same header because you actually need that header to actually get it recognized as still as a executable in this case. But that tool was actually changing the bit order or some of the code blocks in the files, which you can see here in my illustration. So in some cases, the second block of code was like green, was in the second position. In the variant 2, it was actually in the fourth position. And even some of the samples were not being able to run because the code was so much changed in order that actually if you try to execute it, it won't work. But still, the AI model would think like, hey, I still recognize this as Ryuk. So if you do this enough, your machine learning model that is created on Ryuk, for example, will get poisoned. And that was really, for me, one of the first cases we actually observed when this was happening. So we reported this to the instance where we saw all those samples happening, and they blocked the user from submitting. But overall, it was really, really a fascinating process to see. So I would say the net result of using those combined skills and science is like, yes, we improved endpoint and network detections. the big thing was like we submitted multiple patents. But also, not only on Riot, but in other cases, we were successfully able to disrupt ransomware actors, and they didn't even notice. So that's good. But also what we learn here is stuff we actually share with law enforcement agencies around the world. And as a result of that, we were actually able to get ransomware actors arrested a few years ago as a first result. So mixing the skills of our people with science is absolutely great. And I would really encourage you to actually look at that as well. So when I started with this picture of this painting, where I was like, hey, does it always look like the bad guy, so the devil is actually winning this play of chess? No way. I think if we're creative, if we team up the right way, and if you actually analyze this game of chess, you would actually see that the human being can actually make one move. And with this one move, he will actually do the checkmate. And that's where we need each other. We need each other to cooperate. We need each other to learn. And if we share, if we learn and contribute to each other, we will definitely put a checkmate to the cyber criminals. And with that, I really thank you for following this presentation. And back to the host.
Christiaan, you've even finished a little bit early. You've given us some extra time. Thank you very much indeed. Very interesting. Another person to introduce chess, Ramses did it as well, into part of your presentation. I think it's quite an important one, isn't it, though? Because chess can be used in many ways, and the way we as individuals analyze what is, or we try to analyze what is going on, but there are always unknowns.
Absolutely. I think most of the time when you look at how people are, or actually in general are we researching, it's only looking at the first or second move. But I think we need to be far more ahead of the game and actually try to predict what would be the next couple of moves and anticipate on that and actually put our regulations or our countermeasures on top of that.
Certainly an interesting analogy. Thank you very much. I'm sorry I got your name slightly wrong. I should have been Beek, yes? Is that slightly closer?
No.
Your family name?
Actually, no, it's actually Beek.
It's Beek, rather. But I said Beek, you see, at the beginning. So I apologize for that. So it should be Beek. Okay.
No worries.
Yeah, it's Dutch. Excuse a poor Englishman. Christiaan, thank you very much indeed.
You're welcome. Thank you.